So we left off solving first degree trig equations by comparing them to polynomial equations. We're going to do the same thing here with trig equations. So let's say we have an equation represented by 2 sine squared minus sine equals 0. So now comparing this to something that we know how to do, to x squared minus x equals 0. So the way we solved second degree equations in the past was standard form, factor, set each factor equal to 0, solve for x. We're going to do the same thing here with sine, with cosine, and with tangent. You're going to put it into descending order. You're going to factor it. You're going to set each factor equal to 0, and you're going to solve separately. Just recall that there were 3 methods to solve second degree functions with polynomials. There was factoring, completing a square, and the quadratic formula. All 3 may apply here with second degree trig functions. So if it helps, change it to x, solve for x, but don't forget we're not solving for x, we're solving for theta, so that's what sine theta equals. So if I go ahead and solve this polynomial equation, I have a GCF of x, leaving me with 2x minus 1 equals 0, and now I have 2 factors that contain the variable, so I'm going to set them both equal to 0 and solve them separately. So I get x equals 0 as one possible solution, and I get x equals 1/2 as the other possible solution. So now, trouble is, we're not solving for x, we're solving for theta. So this is what sine theta equals. So after we solve, we're going to have a common factor of sine theta, divide both terms by sine theta, and you end up with 2 sine theta minus 1 equals 0. Notice, same thing, sine theta is x. We have 2 factors, set them both equal to 0 and solve separately. Sine theta equals 0. And 2 sine theta minus 1 equals 0. Well, this isn't solved yet. This says sine theta equals 0. So let me get rid of this work over here and try to determine where is sine 0. And the way I'm going to do that is by going back to the unit circle. So sine is the y-coordinate on the unit circle, and the y-coordinate is 0 here and here. We're not going up or down any at 0 and at 180. So those are our 2 solutions for this side, 0 and 180, because that's where the y-coordinate is 0 on the unit circle. Let's add 1 to both sides. 2 sine theta equals 1, and divide by 2. Sine theta equals 1/2. So now that's not solved yet. This is what sine theta equals. We want what theta equals. So before we do anything, just go back to solving first degree trig equations. Before we do anything, we have to determine that sine is positive. Well, sine is positive in quadrants 1 and quadrant 2. So that means we're looking for a first quadrant angle, and we're looking for a second quadrant angle. Let's find our reference angle, and that will tell us how far to go into each of these quadrants. So if you take the inverse sine of 1/2, or the arc sine of 1/2, you should end up with a reference angle of 30 degrees. Well, that's telling us to go 30 up in the first quadrant and 30 up in the second quadrant. The x-axis is 180 degrees, and we're 30 before that. So we're going to have another solution of 150. So in this case, we have 4 solutions. We have 0 and 180, and we have 30 and 150. So our solution set, theta equals 0, 30, 150, and 180. 4 solutions. Second degree trig equation can have a maximum of 4 solutions. It might have 3, it might have 2, it might have 1, but a maximum of 4 solutions. And that's because a first degree trig equation can yield 2 solutions. And the second degree transforms into a pair of first degree equations. Let's do another one. So let's say we have 4 cosine squared minus 3 equals 0. So in this case, we can't factor it, but what we can do, we can add 3 to both sides and take the square root of both sides. So 4 cosine squared theta equals 3. I just added 3 to both sides. I can divide by 4. Cosine squared is equal to 3 over 4. And now when I take the square root of both sides, don't forget the square root can be positive and negative. So cosine is equal to, that's the square root of cosine squared is cosine, positive or negative radical 3 over the square root of 4, which is 2. So this is also a special right triangle value. And if you take the inverse the inverse cosine of radical 3 over 2, you're going to end up with a reference angle of 30 degrees. But before we do anything, let's separate this plus and minus and say that cosine equals positive radical 3 over 2, and cosine equals negative radical 3 over 2. So this says cosine is positive. So we're going to draw our unit circle and determine where is cosine positive. Cosine is positive in the first quadrant, cosine is positive in the fourth quadrant. So once we find our reference angle, we're going to be going up that many degrees and down that many degrees. For this side, this says cosine is negative. Well, cosine is negative in the second quadrant, and it's negative in the third quadrant. So on this side, we're looking for a second quadrant angle and a third quadrant angle. So once we find our reference angle, we're going to have to go up that many degrees and down that many degrees. So let's find a reference angle here. Our angle is the arc cosine of radical 3 over 2. And the inverse cosine of radical 3 over 2, if you put it into your calculator, just remember that this is a special right triangle value, 30 degrees. Well, let's go back down here. That's just our reference angle. We want to go 30 degrees up and 30 degrees down. So 30 degrees up, we have it. That's our first quadrant angle. But 30 degrees down, the x-axis is 360 degrees here. We want to go 30 degrees down. So that's 330 degrees. There's our two solutions for this side. Now let's get our two solutions for this side where cosine is negative. Again, take the inverse cosine of radical 3 over 2, and you should get 150 degrees if you plug it into your calculator. But if you don't plug it into your calculator, you should just realize, well, radical 3 over 2 is a special right triangle value. So I have a reference angle of 30 degrees. That reference angle of 30 degrees is going to go up 30 and down 30 because we want a second quadrant angle and a third quadrant angle because cosine is negative in the second and the third quadrant. Well, the calculator gave us the second quadrant angle. So if we were strictly using the calculator, it would be up to us to determine that this is a reference angle of 30 degrees, which means we want to go 30 degrees down. Well, this is 180. If we're 30 before it, 150. If we're 30 after it, 210. So here are our four solutions. We have theta equals 30, 330, 150, and 210. Let's do one more. Now we have tan theta times tan theta minus 1 equals 12. Let's distribute the tan theta, giving us, let me just change the font on this, tan squared theta minus tan theta equals 12. Now we'll subtract 12 from both sides. Tan squared minus tan minus 12 equals 0. If you're having trouble factoring this, call it x. So what we're trying to factor is x squared minus x minus 12 equals 0. Those factors are factors of negative 12 that add to negative 1, so that's negative 4 and positive 3. Well, there's our factors, but we're going to use tangent, not x. This will simply help you factor it. Don't solve it like this, because I'm afraid you'll leave it as x equals, and you'll say tan equals, and you'll be done. You'll forget to take the inverse tan of both of your sides. So we're going to have tan theta minus 4 times tan theta plus 3 equals 0. So now we have two factors. They both contain a variable. We're going to set them both equal to 0 and solve separately. So we have tan theta equals 4 and tan theta equals negative 3. So let's solve these one side at a time. First side said that tan theta is equal to 4. Well, that's a positive number, which means tangent is positive. Tangent's positive in the first quadrant and in the third quadrant, which means once I find my reference angle, I'm going to go that many degrees up and that many degrees down. So let's find that reference angle. Let's make sure I'm in degree mode. I am not. Okay, second tan of 4 And our reference angle around to the nearest hundredth, we'll say 75.96. Remember that this is only a reference angle. So this is 75.96. Well, that means this is also 75.96. Well, this is 180. We're 75.9 after that, so we're going to add 180. Plus 180. And, well, not what I wanted to do. Minus 1800. Extra zero in there. 180 plus the reference angle, because we're past 180 degrees, gives us 255.96. So not only 75.96, we get 255.96. Well, that is a third quadrant angle, so make sure it makes sense. The second side, we're done with this now. It also said that tan is -3. So we're done with this side. These are our two solutions for that side. Over here, tan is -3. Well, if tangent's negative in the second quadrant, and tangent's negative in the fourth quadrant. Only sine's positive there, and only cosine's positive there. So once we find our reference angle, we're going to go that many degrees up, and we're going to go that many degrees down. Only problem is, we're going to express this as a positive angle by finding a coterminal angle. So let's find the inverse tangent of 3 to find our reference angle. Second tan -3, enter, and -71.56. -71.56. Now, this is a negative angle. That's this angle. -71 is traveling down first. So this reference angle is 71.56. Well, so is this, 71.56. So now you have to visualize, am I saying 180 plus the angle, or am I saying 180 minus? One before, so I'm going to say 180 minus this. 180 minus the reference angle. Remember, reference angle is a distance, so it's positive, 71.56. And we get 108.44. So theta equals 108.44. Let's convert that first angle and find the coterminal angle. So I'm going to get rid of all this because it's getting a little messy. So now what we had was -71.56. Let's find that angle, coterminal, and to get the same spot, let's just express it as a positive angle rotation. And the way I'll do that, 360 minus 71.56. 360 minus 71.56, enter, and our coterminal angle is 288.44. Okay, notice this and this are the same angle. I just found a coterminal angle because we don't want to express angles as negative angle rotations.